All right, we are going to continue our discussion on the ellipse by analyzing one equation. And I'm going to go through this very completely, so we're going to find all of the important parts of our ellipse, if they exist. So we're going to be looking for the center, the two foci, the two vertices on that major axis. We're also going to kind of find the other 2 points on the minor axis so we can draw a nice complete picture. We will also find any intercepts, if there are any, and talk about how to find them. But what we're first going to do is we're going to attack this problem as if we don't know what it is, first of all, and talk about how we know kind of where we're at. We do have one other type of graph that we'll talk about, and that is our hyperbola. But that'll be in the next section, and I'll discuss how we can tell it's not a hyperbola and it is an ellipse here. So, and how to tell if it's a circle, if it's a, whatever. Okay, so here we have this equation with some x's and y's. So first of all, we are just going to be in x's and y's. We have only 2 variables, not 3. That becomes a whole new world, because that's 3-dimensional stuff, and we're not going to go there. So we're going to stay in the 2-dimensional world, the x and the y's. I also see that I have an x squared and a y squared, which tells me, first of all, that it is not a straight line, because a straight line doesn't have squares in them. I also have both the x squared and the y squared, so I know it's beyond the parabola, because a parabola only has a single x squared or a single y squared, does not have both. I know that this is an ellipse for the following reason. I know, well, could be an ellipse. It could be something that doesn't work, but we'll talk about that as I'm solving this. I know it is not a circle, because for it to be a circle, what you will see is the coefficient in front of the x squared and the y squared will be the same. So if they are the same, so if they're both a 4, it would be a circle. Or if this was both a 1, it would be a circle. Okay, since these are different, we have possibly the ellipse or the hyperbola. The way you can tell that it is an ellipse and not the hyperbola, they are of the same sign. So these are both positive, so we have an ellipse. If they were both negative, I'd throw everything on the other side and make them both positive, and we'd have an ellipse. The hyperbola, one is going to be positive and the other one's going to be negative. And that's what we'll get when we see the hyperbola. But that is to come. So, what we are going to do is we are going to see, first of all, do we really have an ellipse? I've already ruled out that that's the only thing it could be. So to find out, we have to complete the square to death. So what I'm going to do is I'm going to group my x pieces together and my y pieces together and throw my constant on the other side. So I'm going to take my 4x squared and I'm going to pull that with my negative 8x. I'm going to leave a space because I have to complete that square. I'm going to have my y squared plus my 4y. I'm going to leave a space and I'm going to move that 4 over to the other side, so I have a minus 4. I also need to pull this 4 out of these x pieces. So I have actually an x squared minus 2x in here. So I'm going to pull it. And if I had a number in front of that y squared, I would pull that out of both pieces here as well. So now I'm going to complete my squares. And my 4 is staying out here. So I'm going to take my x. The method is to take half of this, so minus 1, and then we square it to put it in here. So half and then squared. Do the same thing for the y. We're going to take half and then square. Okay, and now we can't just put things on one side without adjusting for it on the other. So when I put this 1 here, this 1 is actually being multiplied by this 4, so actually I'm adding a 4 when I put that 1 there. If this had been a 7, I would have been adding 7. By putting this 4 here, I also added 4. So what I add to one side, I have to add to the other. And now I'm going to get, and do this side here, so I get a 4. Now, if this had turned out to be a negative number, if this had been negative, then we would have the empty set. The empty set. There would be nothing that would make that work, because we have something squared here. That's positive. We have something squared here. That's positive. We're adding it together. So we have positive plus positive equaling negative. Not going to happen. That will not happen to you in your homework, but in the real world, you never know. So this should turn out to be a positive value of some sort. If it turned out to be negative, you probably had an error somewhere. My guess, it would be something with the 4 times the 1. So if I'd put a 1 here instead, and then we had a couple of those happening. So be careful. Now what we need to do is get it into the form, which means we need a 1 here. So we're going to divide everything by 4. So I have 4x minus 1 squared divided by 4 plus y plus 2 squared divided by 4 equals to 1. These look similar, but notice I do need to reduce this. So this is going to turn into a 1. So I get x minus 1 squared over 1, y plus 2 squared over 4 equals to 1. So notice this number is larger than this, so that means we're going to be going up and down. Yeah, because we're going to be going larger on the y. So this is my a squared, this is my b squared. So I'm going to start drawing a little picture. So my center, first of all, I know where that is. Center, that's your hk. That's with the x's and the y's. So that's at 1, negative 2. So 1, negative 2. I'm going to put a dot. Okay. B, that means the direction, this direction in terms of the x's. I'm going to go the square root of 1, which is 1. So I'm going to go here, and I'm going to go here. So this is 1. My a is 2, so that's going to go up 2 and down 2. And I can draw my little picture. Okay, so from this, I can get my vertices. Vertices are going up and down, because there's my major axis. This would be considered the minor axis. Major because it's longer. So my vertices are going to be at 1, 0, and 1, negative 4, because my a was equal to 2. I still need to find my foci, which are inside my circle here. So I need to find that c. And c squared is a squared minus b squared. C squared is that 4 minus 1, which is 3. So c is that square root of 3. So that means my foci are going to be up the square root of 3. So from negative 2 up the square root of 3, and negative 2 down the square root of 3. So there's my little square root of 3 in there. And there's everything we need to know about that ellipse. We can find the x and y intercepts. These did turn out to be nice, and we found them in our picture. But suppose we didn't have them in our picture. Suppose we had to find them, and I'm going to just verify that yes, we only have one, and we're going to find them as we would. So we're going to find those x and y intercepts, because we could have had more than one. Suppose we didn't, maybe if this had been 2, we would have gone out more, and this had been 3, so we would have gone out. Suppose it had looked like that, we would have had 2 x-intercepts, or 2 x-intercepts and 2 y-intercepts. So let's just verify that yes, we only have one of each, and they are where they are. So So I'm going to go back to the original equation. I'm going to pull it back up here. There was our original equation. And we're going to find the x-intercepts first. So that means we let y equal 0. So that means we have 4x squared minus 8x plus 4 equaling 0. I'm going to divide everything by 4. And then I'm going to try to factor it. Since my leading coefficient is x squared, I'm going to just have x and x to get 1. Well, that means we're going to have a minus 1 and a minus 1. So that means that x is equal to 1 is my x-intercept. And notice we did have 1. We could have had it factor differently. We might have even had to go to the quadratic formula to find them. If I'm finding my y-intercepts, we let x equal 0. So in this case, we'd have y squared plus 4y plus 4 equal to 0. So again, we're going to factor. So this is going to bring back a lot of old friends. Factoring, solving quadratics, the quadratic equation, which you guys hopefully remember, negative b plus or minus square root b squared minus 4ac all over 2a. All right? And some people sing that, right? Negative b plus or minus square root b squared minus 4ac all over 2a. And that was really poor. But, okay, let's get back to this guy. Notice we do get that x plus 2 twice. And so that means y minus 2 equal to negative 2 is our y-intercept. And that was what we had found in our picture. Bring back the picture a little bit. So we have found all the important pieces. We found our center, we found our foci, we found the axes on the major axis. I could find the vertices on the minor axis. I found one. This one would have been the point, where would we be? 2? 2, negative 2. I found that guy. So we found all our vertices, we found our foci, we found our x-intercepts, we found our y-intercepts, if they existed. And therefore, we've done it to death. And we drew it, roughly sketched it. So there is our ellipse. In the next videos, we will be looking at the hyperbola, which is a little bit more complicated than the ellipse, which is a little bit more complicated than the parabola. But we'll do that in the next video. See you there.